Hey, lovely humans. My name is Dana Strickland. I'm a licensed professional counselor in the state of Arizona, a certified clinical trauma professional or CCTP, and an MDRIA certified therapist. Thanks for tuning into this mini-series where we'll be covering the neurophysiological response to stress, i.e. fight, flight, or freeze response. Before we define trauma and what complicates it, then we'll move on to the adaptive information processing or AIP model, which is the foundation of EMDR. Finally, we'll end on some resourcing or grounding activities that you can use to help yourself and your clients. A quick warning before we really get into it, I nerd out for the brain. It does some really amazing things, and sometimes when we feel the most out of control, our brain is doing exactly what it should be doing, just not always for a reason that we're able to easily recognize as being logical. This is why before I get into the nitty-gritty talking to clients about trauma, I talk to them about what their brain is doing for them because it helps us to better understand what's happening to us as the result of what we've been through. And a lot of times what I found is that when people really understand this process, they're able to be more compassionate with themselves and others, as understanding that our reactions to things, especially the ones that we are probably not the most proud of, that they don't mean that we are defective or broken or a bad person. It just means that we're human having a human reaction to a hard situation. So as we're walking through this process, we're going to start with the neurophysiological response to stress, i.e. fight, flight, or freeze. And in order to do that, we have to talk about the structures of the brain. And as we're talking through the structures and the functions of those pieces in the brain, I'm going to be using my super awesome brain glove. Got it on Amazon. So when you put it on, you're going to notice that the outside or the top of the glove shows the major regions of the brain, while the palm side of the glove shows more specific features. The first stop on our tour through the human brain is the anterior cingulate cortex, or the ACC. The ACC is one of the most important information systems of the body. It sits over the top of the corpus callosum, and if you don't know what that is, no worries because we'll get there. It acts as an environmental filtering system, assessing for potential threats in the immediate environment based only off of sensory input from the body. So sight, taste, touch, smell, sound. To quickly summarize, the information is taken in first by the ACC in real time, whether you're awake or asleep, and it can most effectively gather this information when your body is in a calm and relaxed state. The ACC has the greatest reach and impact on affective, which means how we're showing emotion on our face. Our emotional processing that happens in the prefrontal cortex. This is called our noticing brain, or what I like to call our adulting brain. And it also has the greatest reach and impact to the amygdala, the limbic system, and the brain system, which is also part of our survival or cave person system. It is extremely sensitive to dysregulation and changes in your environment. So as promised, we're going to stop next at the corpus callosum. This is really just the communication center of the brain. It passes information from one part to another. So if you think about an operator switchboard or a cell phone tower, it works very similarly. As a side note, when our brain is forming in utero, if the structure of and the location of the corpus callosum is just a little bit off kilter, that's what causes clinical ADHD. So the next structure that we're going to focus on is the amygdaloid body, or the amygdala. The amygdala is responsible for using that sensory information to make a lightning fast decision about whether or not our environment. And as a side note, something really important to think about is that our survival brains cannot tell the difference between life stress and life threat. It also cannot differentiate between what's literally happening and what we are perceiving to be happening. So if you're awake and a bear is literally attacking you, or you are asleep and dreaming that a bear is attacking you, can't tell the difference, your body's going to react the same way. Fun stuff, huh? So the information is sorted based off of whether or not the stimulus is perceived as a threat to your emotional or physical well-being. If a situation is assessed as safe, secure, no threat, then the information is going to be sent to your prefrontal cortex. If the situation is assessed as unsafe, insecure, or a possible or actual threat, then our brain is going to send this through the limbic system and to the brainstem to prepare our bodies to fight, flight, or freeze. So when we go into a stress response, our brainstem is triggering us to release adrenaline and cortisol, both as neurotransmitters and hormones. A neurotransmitter is just a short burst, so to taking a message from one neuron across the synapse to the next. Hormones, like a tidal wave going through your body. And as this is happening, we have changes to our blood pressure. So if we go into fight or flight, our blood pressure is going to go up pretty high. If we go into freeze, our blood pressure is actually going to drop pretty significantly. The blood flow of our brain is redirected away from our ACC. So it impairs our ability to effectively assess our environment. And it's also going away from the prefrontal cortex. The purpose for that is, again, to go back to this bear attack situation. If you were about to be mauled by a bear, you do not have time to debate yourself on what's the best mode for survival based off of what you've seen in documentaries or read. Our back brain says, no, boo-boo, we don't have time for that. So we're going to fight and try to defend ourselves if that seems like a feasible option. Probably not. Or we're going to flee and get out of the way, or we're going to freeze. So it is important to remind yourself and remind yourself and remind yourself again that we are not intentionally choosing fight, flight, or freeze. It's our body making the decision for us, specifically our amygdala, just to keep us alive. That's its only function. So again, blood flow is redirected from the ACC and the prefrontal cortex. And in the rest of our bodies, our blood flow is shifting away from our core, stomach and digestive systems, out to our extremities, which are the arms and the legs. Our muscle tension is increasing. Our breathing patterns are going to change from slow, deep breaths and it will change to short, shallow breaths. Our perceptions are going to shift away from objectively assessing what's actually happening in the moment, and it's going to move in the direction of worries and fantasies, bad memories, repetitive negative thinking. Our awareness is also shifting. Cognitively, we're not in the present anymore, but we've gone back as far back as we have memories of something that feels similar to us, or has caused us to have similar emotions or similar thoughts about ourselves, significant people in the world as a whole, and the meaning of actions and behaviors. And it's taking all of that history, whether it's one similar experience, 10 or 50, and it's plopping those right over the top of whatever is happening right now. So if you have ever had an experience where something on the outside seems really small, but your reaction seems really big and out of proportion, or if you've seen someone else doing that, that's what's happening in your body. This is why calm down never works, because our brain is not in the space where we can assess that and realize that we are safe and it's okay for us to relax. That is a function of the prefrontal cortex, which is offline at the moment. Our body is going to kick into those internal conditioned dialogues: fight, flight, or freeze. And again, these are not intentional choices. These are just survival mechanisms. Our object recall is impaired, as well as our language ability. So this means where when I'm calm, I can tell you that that's a lamp and a phone and my glasses or a pen. But if I get really stressed out, then that's the thing, and I need the thing, and I can't find the thing, and what's happening, and some 4-letter words are going to start coming out. Our logic and reasoning is shifting. Our moral reasoning lessens or disappears altogether. We're reacting to perceptions. We're ruled by history and impulse rather than being intentional and thinking ahead about possible consequences of whatever course of action that we tend to take. The past is running the show. We become more volatile, and our sense of identity lessens. So this whole process is going to be fully engaged in your body from the time that something has triggered your amygdala to think that you are unsafe, insecure, or being threatened. And that whole response is going to happen, if you've never experienced a traumatic event before, in 0.9 milliseconds. And just to put that in context, that is faster than 400 miles per hour. Holy mess. What happens then if we have repeated exposure to stress is that our brain, because it doesn't like to be caught off guard, it likes to be really skilled at what it's doing, is going to start to shave time off of 0.9 milliseconds. So let's circle back. We're in this stress response, and we know that the threat is past, the bear is gone. Somehow, miraculously, we've made it. But that doesn't mean that we're not still rattled. Our body is going to take 18 hours, assuming that we have no other additional stressful stimulus within this time, 18 hours to come back to a chemical homeostasis. I don't know one person who goes 18 hours without some kind of stress. So that's without physical pain, without things, just small bits getting on your nerves, without being hangry, without being too hot, too cold, whatever. So we're going to pause there before we move into our next space, where we're going to be defining trauma and what that looks like, what makes it worse, what makes it chronic. Thank you.